In this lecture, we are going to implement the scanning functionality of our Python tool, which is the main, the core feature of this our port scanner. Since we are creating a port scanner, which will perform different types of port scan, given a target IP address and the type of scan specified. So we are going to take a look at the various port scanning techniques that are available. And the first one that we are actually going to look at is the Tcp Connect Scan. So Tcp Connect Scan is a Connect Scan that is created as a result of three-way, what we call TCP three-way handshake between a client and the server. Now, if the three-way handshake takes place, then communication has actually been established. So this diagram represents how a TCP connect can take place. So we have the client who wants to establish a connection with the server. We first of all send a SYN packet, a packet with a SYN flag over the particular port that it wants to communicate with the server. Now, say this client wants to access a web page from the server, and we know that the web application uses HTTP protocol, which runs over port 80, or HTTPS, which runs over port 443. Now it's going to send a SYN packet, a packet with the SYN flag over port 80 to the server. Now the server will now respond with a packet containing SYN and ACK flag. Now then the client will now know that the server is up and it has responded that that particular port is open for connection. Now the client will now send a packet that has an RST and ACK flag to the server. So then a TCP three-way handshake has been completed, and now they can communicate over that particular port 80. The client can request for a web page from the server, and then the server will respond over that particular port back to the client. All right. So once we have this TCP Connect Scan full completed, then we can see that particular port is open. Now, however, if the client sent a packet with a SYN flag over particular port that it was to communicate with the server, now and then the server responded with a packet containing the reset flag, then we can conclude that that particular port is closed. So when we receive a packet containing a reset flag from the server, then we can know that that particular port is closed. So now back to our algorithm. So we have successfully achieved step number 2, that is create a functionality to process the port and return to us a sorted port list, and we have achieved that in the previous lecture. Now in this lecture, now we are moving over to step number 3, which will perform a scan. But the scan, we have several types of scans, so we are going to create a function to achieve the different types of scanning techniques that we have available. So the first scan that we are going to try to achieve is the TCP scan. As we have seen earlier, as we have seen how the TCP scan takes place. So we have an algorithm that we are going to make use of, that we are going to code into Python's using Python in our port scanner program to try to achieve this particular algorithm. So first of all, we are going to send a SYN packet, and then if to the particular computer that we want to perform the TCP scan on, and then if a response is SYN ACK, then we are going to send a packet containing the acknowledgement flag, a reset flag, and then now we can know that it's a TCP three-way handshake has been fulfilled, and we know that that particular port is open. And then if the response happened to be a packet containing a reset flag, and not a packet containing a SYN and acknowledgement flag, then we know that that particular port is closed. And then if we didn't get any response at all, then we can say that that particular port is filtered. Perhaps there's a firewall that is blocking our scan request. All right, so now we are going to move over to our Python program and then try to create a function to achieve this particular TCP scan. Okay, so now we are going to create a function. I'm going to call that function TCP scan. So I'll just come down here. enter. Okay, so just go up a little. Well, 2 lines is okay. So I'm going to create. I'm going to call that function TCP scan. TCP scan. Okay, and then when I'm going to define parameters so that whenever I invoke this function, I'm going to pass it target, and then the port to scan. Okay, and then the port that is going to scan. All right, so now I'm going to, okay, let me just say port because I'm going to invoke it by for each individual port. So let me just say port. So I'm going to define a target and then the port that we are going to scan using this particular TCP scan. All right, so the next thing we are going to do, we are going to create a variable to stand for the port number that we are going to use to send our scan out of from our computer, the port number that we are going to use to as the source port to send out our scan packet. But before that, for us to be able to carry out this scanning, we need to go and import module Scapy. So this module Scapy also comes in handy in this our tool. We have been using module Scapy before, so as usual, I'm going to come here and import scapy.all scapy.all okay .all as Scapy, and we have been using it to create packet for packet corrupting. So also here we are going to make use of it to create packets. So I'll just go down there, and then now I can make use of Scapy in my program by referring to it as Scapy. So you just go down and continue with our function. So as I was saying, the first thing that we are going to do, we are going to define the source port that we are going to use. So I'll just create a variable and then I'll call it source port. Right, and then I'm going to define our source port. We are not going to make use of any a predefined fix port to send out our scan. So we are going to model Scapy comes with a functionality, a particular function that is used, a class rather, that is to be used to generate source port for the purpose of performing this port scan, and that class is called runShot. So I call it runShot, and then okay, so I'll refer to it as Scapy.runShot. So Scapy .runShot. Okay, so now this will be responsible for generating a short a number that we are going to make use of as our source port. That is where the scan is originating from. All right, so the next thing that we are going to do for us to be able to send out a scan packet, we need to create what we call a TCP IP packet. We are familiar with the OSI model. We know the TCP, Transmission Control Protocol, and then the Internet Protocol. So the combination of the TCP IP will form the scan packet that we are going to make use of to perform this port scanning. All right. So now the next thing that we are going to do, we are going to create the TCP IP packet. So I'm going to call it IP scan packet and TCP scan packet. So first of all, we create the IP scan packet. So IP scan packet, and then for us to create IP scan packet, we are going to invoke from module Scapy. There is a class called IP. So okay, so IP. So here basically we have created an IP scan packet, but though we didn't define the fields that are within this particular packet. And as we have been doing before, we don't know what fields we need to set in this particular packet. So we are going to output the fields that are contained within this class to packet to know what fields we are going to set in order to get the this IP scan packet up and running. So as what we are going to do, we are, as usual, we can invoke the Scapy.show method or Scapy ls or Scapy.summary. So these are all functions that will give us information about the packet that we are attempting to create. So I'll just say IP scan packet, IP scan packet dot show, and then when I go back, then I can go and invoke this TCP scan packet and then pass it target and port, and then see what I'm going to get out of that. Okay, so let me remove this print. We are not interested in printing out the port. We are interested in using the port to actually perform a scan. Okay, so set port. Okay, so let's see how we are going to do, because set port will actually return port for us. So I can say okay, so let me say port, because to set port is going to also port now be a list returned by function set port. All right. Okay, so and then we have IP scan packet dot show, and then this will just print out the okay. So let's let's not let me target the show packet. All right, so let me comment this one out. Even if I invoke it, all right, no need to invoke it, but let me instead of here, since let me do away with this for now. Let me do away with this for now. Let us print this IP scan packet, and then let's see what we are going to get out of that. So print. Okay, we don't need to print since we have invoked show method. So let's just come and invoke this particular function, TCP scan without passing any argument, and then let's see what this is going to print out for us. TCP scan. Let's see what we are going to get as output. So I'll just go over to the terminal and then run this tool, and then see what we are going to get. So we have specified the positional argument, which are very essential. All right, so let's see, without even specifying the port. Okay, but we are going to have an error. All right, we're going to have an error that we need to specify in the port. Okay, so now we are going to run this script. Now let's navigate to the directory that contains the script. So cd okay, so on my desktop coding okay, cd coding, and then the lectures. All right, so my lectures directory now, so I can sudo, so I can now run it. All right, so let me run it and see. All right, no file. Okay, so it is sudo python 3 python 3, and then port scanner.py, and then we can pass the type of 10.0 to 19, and then what we want to scan, we want to perform a TCP Connect Scan, and then the port that we want over port 80. All right, over port 80. So let's run it and see. Okay, I misspelled sudo. It is supposed to be sudo, not sudo. All right, so sudo sudo python 3 port scan.py, and then port 80. So let's run it. Let's see. All right, so perfect. That is what I'm expecting to get. So we have the these are the fields for the IP packet. Okay, for the IP packet. So here we need to specify the destination that we are sending the packet, that we want to send that particular packet to. Okay, so we need to specify the destination where we are sending the packet. So under IP packet here, we are going to basically just specify the destination of the packet. All right, so let's go back to our program and see how we can go about it. So IP scan packet, we are going to, under the DST field, DST, we are going to specify the destination where we want to send our scan packet. So we just come here and then DST field, and then we are going to, is going to be the target. So next time we import this function, we are going to specify the target that we want to send this particular connection to. So target. Now next thing, we need to go over the other. We say we are going to have our scan packet, which is basically a combination of the TCP IP packet. Okay, so now next thing we are going to define the TCP scan packet. So I'm going to create a new variable. I can call it TCP scan packet. And then now when I have this, okay, all right, okay, so all right, let us also print this one out. Let's print it out. Print IP scan packet, IP scan packet. Okay, so next, then let's proceed with the other packet, which is the TCP scan packet. So TCP scan packet. Okay, TCP scan packet, and then we are going to invoke from module Scapy. We are going to invoke another class called TCP, and then we are going to also see the fields that we need to specify in this particular packet. Okay, so are we printing this out? IP scan packet dot show Okay, then we also have TCP scan packet, and then let's also invoke let's have just a demarcation between them so that there won't be any congestion. So let me put a demarcation. All right, just anything to separate between the two output. Okay, so here we have known what the field that we are going to specify, which is the target. Okay, but here we don't know what field we are going to specify. But next time we invoke this function, we have to pass targets to it as argument. Okay, let's also define port, but we are just going to make use of one port. We are just going to input one port using the -p option, so that we won't have issues, because when we have several ports passed as a list, our program will not know how to go about processing performing the TCP scan with several ports. Okay, so let's we have TCP scan packet, then scapy.tcp. Okay, now so let's also invoke method show. So just TCP scan packet, TCP scan packet dot show. Okay, so let's see what we are going to also have as output. Okay, so now when we invoke TCP scan, we are going to pass option.target to it as argument, and also we are going to pass ports. Okay, so when we go off here, we are going to define port. Okay, let me leave it as port, because we are actually going to pass only port to it. We are going to see why we are going to do that. So let me go to the program now, go to the terminal, and then run this program and see if there's any error. We go back and rectify the error. All right, perfect. So we didn't encounter any error. So as we can see, we have defined the destination. Okay, on the okay, did we pass 10.02.19 as our destination? Okay, yeah, we pass it as our destination, so we are passing it. It originated. Okay, let's use a different let's use the input IP address of the Windows 10 machine, which is 10.02.15, and then you run the Python the port scanner Python script again, and see what we are going to have as output. All right, perfect. So as we can see that the packet originated from our source, our Kali Linux, which is having this IP address 10.02.19, and our destination 10.0.2.15. So we have fulfilled the IP component. We just need to pass the destination IP, and we have done that. Now the next what is remaining for us is the TCP packet. Now TCP packet, we need to set several fields. We need to set the source port, and then the destination port, and then the plugs. We need to set that in order to properly perform our port scanning. So that is what we are going to do now. When we go back to this particular packet, we need to set the destination, the source port, the destination port, and then the plug. All right. So now I will just come off here, Scapy TCP scan packet, TCP, and then I'm going to DST port. I can go back to it and look at what the name of the field is. We have S port, D port. Okay, so our S port is the S port. The source port is going to be our source port that we created. The first variable that we created is going to be our source port, and then D port is going to be the port that we are going to pass as argument to the function, which is the parameter here, port. And then we need to define the flags also, and then the flags, since we are sending a SYN packet, remember this TCP scanning, and according to our algorithm we are going to send a SYN a packet with a SYN flag. So this is so under the flag we are going to put S. We are going to send a SYN flag, which is the later representation of the SYN packet. All right, so now we'll save it, and then let's run the program and see what we are going to have again as output. So, and then if there's any error, we are going to rectify that. So let me run the program again and then see what we are going to have as output. Okay, perfect. So we have this. We have export run short. Run short will actually be later on replaced by the number generated by the function by the class run short. Okay, and then destination port is 80. Remember that we inputted port 80. Port 80 now, and then also our flag is SS. So basically these are the three most important fields that we need to send. We need to set the flags, and then we need to send the export, and then the destination port. These are the only three things that we need to set. The other one will be calculated by the packet, our computer will calculate all the remaining other fields by itself. So we just need to specify the source port, the destination port, and then the flags. That are the only thing that we need to set. And okay, but some other important thing that we need to set is the timeout and the verbose level. That will be set under the when we want to send the packet under the SR function that we need to define. But under this particular TCP packet, we only need to set three things. We need to set the source port, the destination port, and then the flag, and we are done with that. Now the next thing we are going to do, we are going to create the scan packet. So basically we have created an IP packet. Now we have created a TCP packet. Now we need to create the actual scan packet, which is going to be the combination of the IP and the TCP packet. Just as we wanted to create an ARP broadcast packet, we created an ETA packet and the ARP packet, and then we combine them together to create an ARP broadcast packet while we are creating our host scanning tool. All right, so likewise here, now I'm going to delete this. We are done with it. It has fulfilled its purpose, so we are going to do away with it. And then also here, I'm going to do away with this. It has fulfilled its purpose, so we are done with it. Now the next thing that we are going to do, we are going to actually create our TCP scan packet. So I'm coming down here and then create a variable called TCP scan packet. So I'll call it TCP scan packet. And then it's going to be a combination of actually the IP and the not IP scan packet and the TCP scan packet. So that will all right, am I making sense? Okay, TCP. Okay, I'm going to call this scan packet, but since we are under TCP scan, we know that this is a TCP scan packet, so that it won't get mixed up with this TCP scan packet. All right, so I'll call it just scan packet. Now after creating the packet, we need to send the packet. Okay, but we can also print out this packet to see how it looks like. So we can invoke method but we have already seen. All right, so let's proceed and also scan packet. Let's invoke method show on it, and then let's go to the terminal and then run it and then see what we have been able to achieve. All right, so run it and then see what we have as output. All right, perfect. So you see we have a packet which is a combination of the IP and the TCP, and it is going to be sent to 10.0.2.15, and it's coming from 10.0.2.19 and through over to port 80, which is the HTTP, and then with S plug, the SYN plug. So basically it is a SYN packet. All right, so we have created the packet, but we didn't send the packet, so we need to now send the packet. So we go back to the code again. So we have done with this. I'm going to delete this. So to send the packet, to send the scan packet, we are going to make use of a method call, of a Scapy method called SR1. SR1. So basically what this method will do is to send the packet and then return to us the first response, because that is just what we need, the first response that the host replies. So, and then I'm going to invoke it using Scapy, since it is a Scapy method. So scapy.sr1, and then I'm going to open a parenthesis. What am I'm sending the scan packet. What I'm sending is the scan packet. So I'm sending the scan packet. And then timeout, I'm going to define timeout so that it won't stay forever waiting for an answer. After sending it for 1 second and the host computer has not responded, then move on to the next computer. Say we have defined fault, okay, or we are scanning several faults. After sending it to one, sending the scan packet over that particular port, they move on and then send the scan to the next port. Okay, so just timeout is going to wait for 1 second before moving to the next port. So, and then also we can set the verbosity level as false so that we won't have any unnecessary output, just as we have been doing before. So I'm going to assign it as false. Okay, so now, but this is going to return something. Then it's going to return the response from the device that we are sending that particular scan packet to. So we need to get the response and assign it to a variable. So I'm going to define a new variable called scan response packet. Scan response packet. So let me call it scan response packet, and then I'm going to, whatsoever method SR1 return, I'm going to assign it to this particular variable scan response packet. All right, so now and then remember, when we have our algorithm, we are going to have a response, and that response might be ACK reset packet, or is going to be a reset packet, or is going to be none. If it is none, then we know that that particular device, the response is filtered. That means that there is perhaps a firewall that is blocking our response. All right, so now let's print the packet actually, to see how the packet is going to look like. So I can just print scan response packet and then see what we are going to have as output. So let me print it out. So print. All right, perfect. So we can see the packet that we have is in bytes. So it's in bytes data type, so it doesn't make any meaning to us. But let's invoke this the summary and see whether it's going to make some meaning. Print scan response packet the summary, and then see how the output is going to change. All right. Now, perfect. So we can see this is a IPTC response from the from 10.02.15 to 10.02.19. It is sending it to port 27497, which was the source packet that we sent that particular TCP scan. And then we have RA/padding that actually contains the data components of this particular packet. So let's proceed to see what we can handle this packet accordingly. So let's go back to the code. Now, instead of printing it, I will remove the print. We don't need to print anything. We're not interested in printing it out. We are more interested in analyzing the response. Okay, and also I want to shorten the name here. Scan packet, instead of saying just scan response is okay. It suffices. And then we are going to go back to our algorithm, and then using our algorithm will guide us on how to go about analyzing the packet. All right, so when we go back to the algorithm, remember we say we are going to send a SYN packet. So we have sent a SYN packet and we have gotten the response. Now, if the response is SYN ACK, then how can we know that this packet is the response is a SYN ACK packet or otherwise? So we are going to analyze the content of this particular packet to see whether we have seen ACK as the response. So to do that, let's also invoke scan response.show. So scan response.show. Let's see the content, the fields that are contained within this packet. So I'll go back again. This is all that we have been doing before. So we are applying the knowledge that we have had earlier to analyze a packet. So now let's see the response. Okay, so we can see the various layers of the response. Remember that we are more interested in the plug, that is associated on the packet. So we can see on the TCP plug we have RA, and then in our own packet that we sent S as the flag. But in the TCP plug here, we can see the plug is RA, which is the ACK reset packet. And then we have our algorithm. We can go to the algorithm and see if we have that particular response, what are we supposed to do? So we have a syn ACK reset. So RA basically means reset ACK. So RA is reset and acknowledgement packet. All right. So we send syn ACK, and then the 10.0.2.15 send back to us an ACK reset packet. Okay, so now we are going to know how we can analyze this packet. Remember, it is in TCP layer, and the field name is plugs, and the value is RA. All right, so let's go back and then see how we can handle that in our code. So we have scan response.show. So we have already seen that. So I'm going to let me delete this. Now, based on our algorithm, we said we are going to send a syn packet, and if the response is syn ACK, then we know that if the response is syn ACK, then we are going to send a syn ACK reset packet, and we can conclude that the port is open. So we are going to see how we can analyze this. So we are going to ask if, using if statement, we are going to check what the response is. Now, if scan response, first of all, we have to check scan response. Now, if scans response, we are going to check if it has a layer, because basically all the syn and the syn ACK, these are TCP plugs, as we have seen earlier in our first lecture. These are TCP plugs, and the TCP plugs, when we run the program here, we can see that it is under TCP layer, and it is under the plug is a field within this TCP layer. So we have to check if the packet even has TCP layer, because before we can start doing any other thing further. So we have to go and check if it has a TCP layer. So we are going to check if scan response has layer. So we are going to invoke okay, if scan response, going to invoke this method called has layer, which is a packet function, a packet method, and then we are going to check for the presence of this layer. Okay, this layer is from Scapy, Scapy.tcp. Then if it has that, then before we can go and perform further analysis, because if it doesn't have the TCP layer, then all we are going to do is going to be in vain. So we are checking that the response that we got from that particular host machine, does it have this layer Scapy.tcp, which is the one that we printed out in this particular packet. We can see the TCP layer, and then under the flag, that's what we are interested in, and that is what we are checking. But also we need to check if even we have a response. What if we didn't get any response? So let's check if we have a response, even if we have any response at all. So to do that, I'm going to make use of if scan response. If scan response is not equals to none. Before we proceed to do anything, let's check whether it is not actually equals to none. If it is equals to none, all we are going to do is going to be in vain. So first of all, make sure that we even have a response at all. So now line number 78 is checking to make sure that we actually got a response. So if scan response is not equals to none, then we can proceed to line number 79, which will now has check whether the packet scan response actually has layer Scapy.tcp. Now, if this two condition has been fulfilled, now we are also going to check if within that Scapy TCP layer we have a flag. The flag that we have is what we are expecting. So if scan response, scan response, and then what we are checking as we have done before. We are checking for the presence of this layer scapy.tcp, and then within that layer we are checking for a flag, the value of this flag. Remember, we go back to our algorithm. We say we are going to send a SYN packet. We have sent a SYN packet, and a response has been received. Now, if the response is SYN ACK, so we are checking for SYN ACK. Okay, and then when we go back to this diagram, SYN ACK, we can see that SYN ACK is going to actually have the decimal value of 18 or a hexadecimal value of 12, which is SA, TCP Packet latest. So we are going to make use of either this 18 or 12 to now determine or the value of the plug that we have in that particular packet. So now I'll go back to this diagram, to our code, and then we are going to check if it is equivalent to okay, let me go back to the diagram again. If it's SYN ACK, if it is equivalent to OX, if we want to make use of 12, then we have to write with the hexadecimal notation or X12. If it equals to 12, then we are going to do something. So we are checking for if scan response Scapy with the flags equals to OX12, or we can say 18, or equals to 18, or it is equivalent to 18. With that is what we're having as a response. It equals to 18, that is in decimal notation. Then we are going to take the appropriate action, and then that will be guided by our algorithm. So if we have SYN ACK, if response is SYN ACK, then we are going to send a reset packet, an acknowledgement reset packet, just as we have in the TCP three-way handshake. All right. So now we are checking for that. So now we are going to create a TCP another packet again, and a reset packet, and then send it to the machine to close the TCP three-way connection. So if these three conditions have been fulfilled, now we are going to create a reset packet. So let me call it a reset packet. So reset packet is equals to. So also to create a reset packet, we are going to go through the procedure we did here. We are going to have a IP reset packet and TCP reset packet, and then combine it to form a reset packet. So let me call this one IP reset packet. So IP reset packet. IP reset packet. All right. So and then we are going to have Scapy .tcp and then under the just as we did here, under the dist, we are going to send the dist as the target, and then we are also going to have an IP reset. No, okay, we have done IP. Then we are going to have TCP reset packet, and then we are going to have it as Scapy dot alright. So I mix here. It's supposed to be IP here, not TCP. So it's going to be IP. Then come down here. We are going to have Scapy.tcp, and then we are going to define all the fields that as we did here. So we are going to have S port. The source port is going to be our source port. Okay, and then our destination port, our D port. Our default is going to be port, and then we have the flags. Now that is what is going to change now. Flags is going to be what we'll go back to the algorithm. We are sending a reset packet, so we are going to send ACK reset packet. So we are going to send an RA packet, reset acknowledgement packet. So I'll just come here and write RA, as simple as that. So that is what we are sending, a reset acknowledgement reset packet. All right. So and then okay. So now this will take care of if we are having a flag of 18. Now let's go back to the algorithm again and then see what we are going to code again. So then we print port is open. So if all these three conditions have been met, then that means that the port is open. So we are going to return that our port is open according to this algorithm of the TCP scan. So if all this procedure is fulfilled, that means that the TCP three-way connection has been TCP three-way handshake has been fulfilled. Then we can know that the port is open, right? So we can all right, okay. So but we didn't send the packet, we only created the packet. So we can say reset packet here, reset packet equals to, so we are going to combine the packet just as we did in the scan response, okay, and the scan response. So scan response, okay, so let's say reset response also instead of reset packet. So let's say reset response that we are sending to the machine, to the destination. So and then we are going to have SR1, which is the method that we are invoking to send the packet. Scapy.sr1 is from Scapy module, so Scapy.sr1, and then we are sending what are we sending? Okay, so we didn't okay, reset response, reset. Okay, I'm going by this. So scan packet. Okay, so reset packet. All right, so it was earlier, right? So reset packet. All right, so let me do away with this, which is going to be the combination of the IP. It's going to be a combination of the IP reset packet and the TCP reset packet. So TCP reset packet. So what we have now, we have gotten our TCP reset packet. So and then we can send the reset response. So we have reset response that we are sending to the machine using Scapy.sr1, Scapy.sr1, and then we are sending reset packet, packet. Okay, so we are sending reset packet, and then timeout also, as we did in the earlier scan packet that we sent. Timeout of 1, timeout of 1, then bubbles false, bubbles false. All right, so that is our reset to close the TCP three-way handshake. All right, so we go back to the algorithm again and then see what we need to code next. So now else if response is reset, that is what we got as a response, a reset from the machine. Then we are going to print port is closed, but there in the other one we didn't return port is open. So reset response, and then we are going to return to whatsoever line of code that invoke this function. We are going to return a string that the port is open. So port is open, or we just return open from our algorithm, because when we said send a reset acknowledgement packet and then print port is open, so we are returning that port is, we are going to return open. Now the other condition is if our scan response is not what we are expecting, that is not SYN-ACK. It's not SYN-ACK. That means it is reset. That means what is the value of the reset flag? RST. That is, it is 4. RST, it is 4 in decimal, and OX4 in hexa value. Then what we are going to send is, let's go back. Then we are going to print the port is closed. So we are going to now check elif using elif if, and now if scan dot response, and then from the layer Scapy, from the layer if scan response, and then from the layer Scapy TCP, Scapy dot TCP dot flags is OX4, or we can say it's just 4. Then what we are going to do, we are going to we are going to go back to the algorithm and check what we are expected to do. Then we are just going to okay, we have to check is reset. Then we are going to return that port is closed. So we go back here and then return closed. So return closed. Okay, so we have that, and then we have else if there's no response, then we can say the port is filtered. So we go back again, and then so that is if our scan. Now if this value fail, if scan.response is none, that means that it's not equals to none, that means it is none, then we are going to have that particular fault is filtered. So if we are going to have a branch here, another condition. Okay, so under the first if, then we are going to have else. That means that this condition, the initial condition failed, is not equals to none, is equals to none, not this condition failed. That means that it is none, the response is none. Then we are going to return that is filtered, that the fault, that particular fault is filtered. So we have successfully implemented TCP Connect Scan. Now we have already invoked it in function line number 99 option.target.port, and then now let's run this program and see what we are going to get as output. If there's any error, then we are going to correct that error. So I'll go to the terminal, clear the terminal, and then retry running this script and see what we are going to have as output. All right, so we didn't have. All right, so the program ran successfully, but we are not printing. We are just invoking the TCP scan option, the target port, but we are not doing anything to what we have as return. Okay, so let me create a variable here and then call it response. So we are going to actually print out the response equals to TCP scan option, the target, and then let me print out the response here. Response. So response, and then let's see the response. So we go back again to our program, run the program again, and then see what we are going to have as output. None. Okay, so we are having none as output. So are we expecting none to have none as output? So when we go back again, let's go back to the program and then make sure that we implement it, because if we did, we could have ended up with an error. So actually non-response is none of the responses that we are expecting, because we are expecting to have open, close, or filtered as our response, not none. So something might is wrong with our code somehow, somewhere. So let's go back and then analyze the code and then see what went wrong, and then see how we can rectify that particular issue. So we know the TCP three-way handshake, we are going to send a SYN ACK, and then if the host is off, is going to reply with we are going to send a SYN packet rather. And then if the device is off and the port is open, is going to reply with SYN ACK, and then we are going to reply with a reset ACK plug. Okay, and that fulfilled the TCP three-way handshake. So we are now checking. Then if the scan response is not equals to none, that means we actually got a response, and then we are checking if the TCP plug is 18, and we know that 18 corresponds to SYN ACK. That means that we got a SYN ACK, we got a response that the port is open from the device. Then we are going to send a reset plug, but we are not sending a single reset plug RST with the value 14. We are actually sending a reset and with a combination of reset and an acknowledgement packet, which has the decimal value of 20 and the hex value of 14. So we can use any of them. We can use either 20 or x14 to represent the hexadecimal value. So okay, so let's go back again and see the issue. It's not supposed to be 4, it's supposed to be OX14. We can make use of 20 or OX14. So let's use 20, which is the RA, which is the reset acknowledgement flag, 20, decimal value of 20. And then see what we are going to run the program, and then see what we are going to have now as our output. So now we'll go back to the terminal again and then run the program and see what we are going to have as our output. So I'll just come up here, run the program, and then see what we are going to eventually end up having as our output. Okay, perfect. So we have closed. So that particular port is closed, and that is that means this function has been implemented properly, because we are expecting 3 response. Either the port is open, or it is closed, or it is filtered. Okay. So now, if we want to get filtered response, let's see whether we are going to get a filtered response, because that means that for us to be able to get a closed response, that means that the firewall on the target machine is off. That means that is why we are even able to get the close as a response. So I'm going to go to the Windows machine, and then I'm going to activate the firewall, and then see whether I'm going to have filtered as my response. So I'll just come here under admins, under system tools, and then I'm going to open my command prompt with admin privileges. So I'll right click and then go to under more, and then run as administrator. I'm going to run my command prompt as administrator, so that I can set the firewall on or off. So currently now it is off, so I'm going to set it on within the command prompt. To enable my firewall, I'm going to run the command netsh advanced firewall, okay, set all profiles states on. So this is a command to enable a firewall from the command line, the host based firewall that the Windows 10 machine has. So I'll just hit enter. So we can see that our command runs successfully. Now that means that the firewall is enabled on this Windows machine. So I'll go back to the Kali machine again, and then I'll attempt running my port scanner again, and then see whether if I'm able to get filtered as a response. That means that our TCP Connect Scan function has been implemented successfully. Perfect. So we have been able to get filtered as our response. That means our TCP Connect Scan is working properly. So in today's lecture, we are going to continue implementing this port scanner